One of the things that many people who study earth science will hear about is the Mohs scale. The Mohs scale was essentially a way to measure the hardness of a mineral. The Mohs scale was named after Mohs, Friedrich Mohs, a German scientist who developed this in the 19th century. So basically how Mohs' scale worked was basically he picked 10 minerals to represent 10 points of the scale. It's a 10-point scale. And basically, all the harder minerals could scratch all the softer minerals. For example, a mineral with a hardness of 2 could scratch a mineral with a hardness of 1, but so could a mineral with a hardness of 3, 4, all the way up to 10. Now, if we take another example, a mineral with a hardness of 6 can be scratched by one with a hardness of 7, 8, 9, 10, but it cannot be scratched by one with any lower hardness. So that is basically how the mineral hardness scale works. At the softest point, Mohs chose the mineral talc, which you can almost squish with your fingers. And then for 2, he chose gypsum. And then it goes all the way up until at scale 9, you get the mineral corundum. And at scale 10, the top is, of course, diamond. It is the hardest mineral in the world. It cannot be scratched by anything else except for another diamond. This is how the Mohs scale works. However, maybe you're noticing a flaw right now. These 10 minerals are obviously not the only minerals in the world. The Mohs scale is relative. It determines which mineral is harder than another, but it doesn't really determine just how hard the absolute mineral is. And the absolute hardness scale is a solution to that. The absolute hardness scale is an objective calculation of how hard a mineral actually is, and compared with the absolute hardness ratings, the Mohs ratings go all the way from a very, very low 1 for talc to a very, very high 1500 for diamonds. So yeah, this is the Mohs scale. It's a very popular scale, and I've just explained how it works, a little bit of its history, and also a bit of its downsides.